I'm Stephanie Jones, Director of e-Business at the SEMA Data Co-op. I've worked hands-on with data standardization since 2003. I've had the opportunity to learn from and work beside some of the folks instrumental in shaping the standards in the early years. I've designed systems and published thousands of data files using the standards and have taught several courses to share my cultivated knowledge. I hope you find useful information in this video that can assist in better understanding the standards and how to use them to benefit your organization. Welcome to the SDC's video training course. Today we're going to talk about creating application data and some of the rules, pitfalls, and best practices to consider. So as you start thinking about how you'll be constructing your own ACES applications, I want to give you a few tips that may help. Okay, so let's start with the rules, application rules. There's a term called overlapped applications, and that's where we'll start today. So each application should clearly point to the selection of a part. So this means that in an ACES file, we need to provide enough components in the application itself that we can clearly differentiate one part from another part that may fit on the same vehicle. But what we don't want to do is have data that's identical on two parts, same vehicle. Then there's no way to tell what's different. So we want to have something that differentiates the two. Otherwise, that's called an overlapped application, and those should definitely be avoided. That's where the term that the data needs to stand alone and be unique comes from. The second part, our rule that we need to follow, is called overpopulation. Now, this is when, on the flip side, we want to make sure that we're delivering only the information that's required to make the part selection. Otherwise, if we're sending a whole bunch of data in our application that really is irrelevant in going through the part selection process, then that would be considered an overpopulated application. So we do not need to include say steering configurations in your application if it's not relevant to the part number itself and selecting that part number. ACES is designed to use the fewest amounts of details for each part number. So think of it as like a consumer that would be clicking through a drill down. We want to make sure that they don't have to go through too many keystrokes and answer too many questions that may or may not affect what part they're going to end up with at the end of the order. So too many irrelevant questions, when too many irrelevant questions are asked, then they're going to leave. So we want to avoid overpopulation in vehicle configurations, and we want to make sure that we're delivering only the information that's required to assure that proper part selection. Okay, the next thing let's cover is vehicle identification best practices. Many of you may maintain your part application data in year ranges rather than having the data broken out into an each year scenario. It is valid to format your data this way in an ACES application. It comes out a little bit differently. Year range and then make is what would be sent in the application to identify the vehicle. This is considered an alternative method, but it is still considered a valid method. The best practice that is suggested, though, is to go ahead and break those years out so that each year is listed with a base vehicle, year, a make, and then a model. The year ranges and makes are not always accepted by all receivers, and typically it requires more information to make good applications. So the preferred or best practice here is to use base vehicle. Let's go over this submodel pitfall next. So here on the screen, we've got an example of two part numbers that fit the same base vehicle. Now, base vehicle is just the ID that's assigned to the combination of the year, make, and model fields. That creates your base model. So we've got two parts here that fit the same base model. Now, if we look down in red where it says submodel, the difference here is that only one of the part numbers fits the submodel limited, and then all of the other part numbers in the list are going to fit all other submodels. The pitfall here is that simply placing limited into the submodel field on just one of the part numbers is incorrect. Now the reason is that we don't want to leave the customer not really knowing if the other part will or will not fit his vehicle's submodel. We don't want to explicitly state submodel on one application and then not explicitly state it on all of the other applications for that given vehicle. So the rule here is to keep it consistent. If you use a submodel in one application, use it in all of the applications for that part number for that given vehicle. So here's a better example that we can look at. This is the proper approach. We've created an application for each submodel that exists for the base vehicle for that application year. So now we spell out the Ford Taurus Limited, the Ford Taurus SE, and the Ford Taurus SEL. So now, when all of this is displayed together, there is no doubt which part number is going to fit which submodel. And the lookup process will deliver a product to the customer when he's prompted for his submodel. So remember, if the vehicle has only one submodel, then you do not need to call it out at all. Or if your part is going to fit, say, all three submodels in this case, you would not need to call them out explicitly. So let's make sure that that last part makes sense. If a vehicle from the ACES VCDB tables only list one submodel, so for instance, let's say that the 2010 Ford Taurus was only available with a base submodel, then you do not need to call that base submodel out in your application because there's no other choices. Then the other one was if your part fits all three submodels. So back to this 2009 Ford Taurus example. If your part number were the same for the Limited, the SE, and the SEL, you would not need to map at the submodel level in this case. You would just leave it out of your application completely. You would not need to call them out explicitly. Next, let's go over another pitfall, the exception pitfall. Here on the screen is an example where we have a product that actually fits all of the drive types for a certain vehicle except the all-wheel drive. Now, e-catalogs do not deal with exceptions very well. So, is listed here on the screen, it's just been added as a note, except for all-wheel drive. The preferred method here would be to explicitly state which drive types do fit the vehicle and then map those applications out. So as we mentioned with submodels, the proper strategy here is the same. We want to create an application for each drive type that the product will fit and omit the drive type that it does not fit. Then there's no question as to whether or not it's going to fit a certain drive type. So here's an example of what it should look like. So we see that we've got the same part number mapped to the 2009 Ford F-150s. Then we're explicitly mapping rear wheel drive, and we're also explicitly mapping the four-wheel drive. This way, a lookup system will understand that those are two valid vehicle selections. Omitted from the application file would be the all-wheel drive. The last pitfall to cover here is with OR logic. So in the same context, OR is not a concept that we want to use in electronic cataloging. In this example, the thought that was being attempted is that the part will fit vehicles with a drive type all-wheel drive or any vehicles with a VIN code of J. So if we were to leave this part number mapped as the example on the screen shows, then the application would be interpreted as AND, not OR. Therefore, it would look like the vehicle must be drive type all-wheel drive and a J VIN code. So the proper method here again is to create two distinct applications showing that the parts map to the all-wheel drive type, and then again we would map it to the VIN code J. The last item I want to bring to your attention regarding ACEs is that you're given two ways to deliver application data, either full files or net delta change files. In the XML, you can flag in the header the action to indicate which one you are sending. So if you're sending full files, this means that you expect your data receiver to completely overlay the previous file with the new file that's being sent to them. Or a full file would be sent to create a baseline if you've never delivered data to this receiver before. So once the initial full file has been sent, you have the choice to either continue sending full file deliveries, or you can send a net change file. You may hear it called a delta file or a net file. They're all the same thing. So in this case, just send applications that are new or have changed in some way. This will append to the existing data. You can also show a record as being deleted. So all of this is managed through the action flags that go along with each record. The pitfall here that we want to make sure that we avoid is incorrectly identifying the submission type in the header record. So we want to make sure that we understand full or update is going to affect how your data receiver is going to bring data into their system. That, accompanied with the maintenance flag that will be included in each application, your add, change, or delete flag, will also affect how your data brings that application into their system. So in review, understanding and following rules while building your ACES applications will help you to avoid errors in your data and incorrect mappings that could lead to returns. And it's always best to create applications following best practice guidelines. And that's it for this video. Thanks for watching.